this polygon. So now we need to know specifically what are polygons and how does triangles fit in with them. So a polygon is a closed two-dimensional shape with straight sides. There are three main examples: a triangle, which is what we're going to use and you're going to see a lot of. Second is a rectangle, which is a four-sided figure, and we're going to get to those later on in the week. Third is a pentagon, which is just another closed figure, and it can continue on with his men. He has 6, 7, 8, 9, 10 sides. We know some figures that are not necessarily polygons. One is a circle because it has a curved side, not a straight side, so therefore it's not considered a polygon. Second is an unclosed figure, or a figure that has points that don't connect to something. And as you can see from the figure onto the side here, there are two points that do not connect. So therefore it's an unclosed figure, which in turn means it's not a polygon. So now we're going to look at some things you need to recognize about polygons, specifically the definitions of sides and angles. Every polygon has n sides, where n determines the number of sides, and which in turn determines the name of that polygon. So, like a triangle has 3 sides, and 3 sides determines that it's a triangle. A rectangle has 4 sides determines it's a rectangle. 5 sides determines it's a pentagon, etc. And it goes on and so on and so forth. So from this picture you can see what a side looks like from this 4-sided figure, and I just want you to get an idea of what a side looks like. So since every polygon is a closed figure with sides, it does stand to reason that they have these things called angles as well. From this picture you can see that we're looking at a triangle with 3 sides and 3 angles, all labeled by A, B, and C. And we're going to get more into that as time goes on. So an angle is the amount of term between 2 straight lines that have a common endpoint called the vertex. And from this picture where it says arm in the blue and the olive colors, those are the 2 straight lines. The vertex is formed by the intersection point between those 2 lines, and the angle is the amount of between the 2 straight lines, and it's measured in degrees. So now we're going to look specifically at triangles. So there are 3 different types of triangles. One is a right triangle, a triangle length, which is a triangle that has one 9-degree angle. And from this picture you can see that there's a 9-degree angle marked, and it is used to specifically design the right triangle. Second, we have an isosceles triangle, which is a triangle that has 2 equivalent sides and 2 equivalent angles, or another word we're going to use later on, which is congruent. And as you look from this picture, the 2 equivalent sides are marked with hashes, and the angles are marked in the corners there by the vertices. The third is an equilateral, an equal angular triangle, a triangle that has 3 equivalent sides and 3 equivalent angles. And depending on what is marked depends on if it's 3 equivalent sides, it's an equilateral. If it's 3 equal angles, then it's an equal angle triangle, depending on how it is marked in your book and in the problems. But both hold true, and if it is equilateral, it stands to reason it's equal angular, and vice versa. From the picture, you see that all 3 sides are equal, and all 3 angles are equal, so this is an equilateral and equal angular triangle. Now we're going to look specifically at what angles mean. So there are 3 different types of angles. An acute angle, which is an angle whose measure is less than 90 degrees. And if you look at the picture, it shows that the angle A is less than 90 degrees. Obtuse angles, an angle whose measure is greater than 90 degrees. And from the picture you see that it is vertices are pretty easy to tell. They're not marked, but they're at all three corners. The base is listed below as the bottom side, and the height or the altitude is that dotted line from the top vertex down to the base, which forms a perpendicular, which is why you see the 90-degree angle. So here's what you need to do for the start of the next class. Write down what you think of all these definitions and properties and how we're going to use them in the class. It doesn't have to be detailed, just enough to get an idea of what's going to happen. I want you to draw your version of a right triangle and an isosceles triangle, one on one side of the paper and the other on the other side, and then bring it to class. And I will see you